reactions are always different for different compounds, but a reaction, you can distinguish between two compounds only when you have some visible change. That means change of color or effervescence, or maybe change of odor. So then only you can distinguish. Otherwise, a reaction is occurring, but you don't have any visible or change of odor, so you cannot really say whether the reaction is occurring or not occurring. So this completes our study of ethanoic acid. Now the next very important topic is soaps and detergents. Now you must have heard about soaps and detergents. So soaps are basically cleansing compounds or cleaning compounds. They clean the dirt. And detergents also do the same. But there are many differences between soaps and detergents, which we'll come across now. Now if we speak chemically, your soap is a long chain fatty acid. What you mean by this is that they are just long chain carboxylic acid. I mean, it can be C17H35COOH or something like that, or C18, C20, all these. So this C17H35COOH is one of the major, it is generally used in the preparation of soap, or actually these are not fatty acids, sorry, they are the sodium or potassium salts of long chain fatty acids. So this is not actually C17H35COOH, it is C17H35COONA or C17H35COOK, and this compound is called sodium stearate. Now you don't need to remember the name of this compound, just for your idea, they are just long chain, sodium and potassium derivatives of long chain fatty acids, long chain carboxylic acids. So what a soap molecule looks like is somewhat like this. That is, this is the sodium ion and this is the long chain, that is C17H35COO minus. So this chain is basically hydrophobic in nature, and this end is hydrophilic in nature. Hydrophobic means water hating. That means this chain hates water. That means if you put this thing in water, this chain will want to stay away from water. And hydrophilic means water loving. That means it loves water. If you put it in water, it will want to stay with the water. So we have a hydrophilic and a hydrophobic end. That means this end will be called the hydrophobic end in the same compound. So an interesting thing is that when you put it in water, when you put some soap in water, suppose this is the surface of water, and you put the soap in water. So what will happen? This hydrophilic end will want to stay in the water, but this hydrophobic end will want to stay away from the water as much as possible. So basically they will accumulate on the surface of water and it will stay like this. That means these hydrophobic ends will stick out from the water surface. And these hydrophilic ends will remain inside the water. So this is just putting soap in water. Now what if there is some dirt in the water? What will happen? Now this dirt particle